Telegraph 0. All recorders slow speed. All recorders slow speed.
This is a static test.
This is a static test. Switch open.
Years before the birth of Christ, the men of Alexandria were already making scientific measurements of the stars and planets. And always, since then, there have been those whose imagination turned their eyes and thoughts to the far reaches of space. And so today, man is positively and truly extending the knowledge and the control of his environment, and for the first time is reaching effectively beyond his own terrestrial boundaries. For the first time, he is studying the sky from the sky. Project Saturn is a major American contribution to this advancement. Saturn is the largest launch vehicle at present under development in the free world. This is a rocket with a 1.5 million pound thrust that will put a 10-ton payload into orbit around our Earth, to the Moon, and into deep space. A later, more powerful version of Saturn will be capable of putting up a payload of 2.5 times this amount, 25 tons. It will be our first major rocket for space exploration, and is being developed specifically as part of an overall scientific engineering program. Saturn uses the building block principle. It is made up of various stages, each of which will drop behind in space as its fuel becomes exhausted. Saturn can be a 2, 3, or 4-stage rocket, depending on the use to which it will be put, and the payloads it has to carry. A 3-stage Saturn will be 185 feet high as an 18-story building, and 22 feet wide at its base. Here is a scale model alongside the first stage of the real thing. Although scaled down to 1/10 size, it still dwarfs a man by comparison. The 2-stage Saturn is planned as a kind of utility space truck to put large payloads into orbit around the Earth. With it, larger spaceships could be refueled before moving outward on longer journeys. Saturn, with additional stages, will be used for probes to the Moon and the farther planets. A 4-stage Saturn will land precision instruments on the Moon. Although other United States rockets may get to the Moon before it, Saturn will put up the greatest payloads. It can obtain information from several areas on a single Moon trip, and later return actual samples from the Moon's surface. Most importantly, Saturn will send a 3-man spacecraft, the Apollo, around the Moon and back to Earth. With refueling in space, it could at last carry man to the Moon's surface. And so in the various industries and universities, under the guidance of the National Aeronautics and Space Administration, research is planned, techniques developed, materials checked out. The key word is precision. And although the space age has but begun, already we have accumulated a great wealth of technical and scientific experience. Basically, Saturn is the outgrowth of mechanisms that have been tested and proven. The first guidance system to be used in Saturn, for example, is an improvement on that used in the Jupiter rocket. However, the guidance system for the Centaur, developed in the Atlas Centaur program of the Space Administration, appropriately modified, may prove much more versatile. It is hoped that it will be capable of guiding Saturn on more complex missions. The Saturn booster has a cluster of rocket engines, so that like a multi-engine plane, one engine may cut out without impairing the effectiveness of the launch vehicle, and the propellant from the inoperative rocket engine will in some stages automatically be put to the use of those still functioning. There are 8 booster engines in the first stage of Saturn, 6 in the second stage, and 2 in the third. In trials, small test models are constructed to scale and tests made to verify, in fact, what has been predicted. In live but captive conditions, measuring instruments register the various thrusts, stresses, and responses. Meanwhile, full-scale production is going steadily forward. Project Saturn's technical demands are widespread and its needs critical, and so at various industrial plants across the nation, the hardware, the airframes, the guidance systems, the instrumentation, and the rockets themselves precisely take their blueprinted shape, ready for assembly. Newly devised parts call for unusual production methods. Undreamed of sizes call for gargantuan frames and molds. For example, this furnace needed to treat an upper stage engine is the largest of its kind. Following manufacture and checkout by the contractor, each engine for the first stage of Saturn is shipped to Marshall Space Flight Center for further trials. Each engine separately undergoes final exhaustive captive tests before it is approved. These gleaming metal tanks plus liquid fuel will send man and his instruments through space at an incredible 25,000 miles per hour. Finally, the uppermost stage, with its 2 engines, will propel the payload through space. This space giant, so swift and responsive on high, is too ponderous and bulky when earthbound to be transported in one piece. Even the separate stages of Saturn require special vehicles to carry them from factory to launching pad. Oversized trucks and barges come into being. Already experience in space technology has the hard-headed engineers talking about cost per pound of payload in orbit as if it were commonplace. An example, 4 years ago it cost between $300,000 and $1 million to put 1 pound of payload into orbit. But past investment is paying off now, as investment today will pay off in the future. Today, with advanced knowledge and increased production, cost has been cut to about $5,000 per pound. By truck and barge, now the stages will finally arrive at Cape Canaveral. Here is the water route Saturn will follow. Cape Canaveral, only a village and a resort a few years back. Today it means just one thing to every schoolboy: rockets. The launch facilities at Cape Canaveral have been constructed to handle both present and future versions of Saturn. The erecting gantry, over 300 feet high, is the tallest movable structure in the world. It has direct connection with the blockhouse, from which and to which all signals come. Signals from the electronic tools which tell how the rocket is performing, and without which there could be no launch. More than 900 separate channels of information are relayed from the rocket to the recording and control equipment in the blockhouse. We have come far since the men of Alexandria made their primitive observations of the heavens. Our space age is just beginning. We do not yet know where it will ultimately lead us. But we do know that Project Saturn will vastly increase our understanding of the universe and our potential to travel into space.